Hello and welcome to our asynchronous lesson on the prerequisite chemistry for AP Biology. So the first thing I'm going to review with you has to do with how electrons fill the energy levels. So this outer energy level is known as the valence level. And within the valence levels are going to be things we call orbitals. And each of the orbitals can hold up to 2 electrons. And what happens is all the electrons will fill from the inside out, and the remaining electrons, so the first energy level will hold 2 electrons, meaning it has 1 orbital. The second one, which this atom on the screen is showing, has a second orbital or second energy level, which will have 4 orbitals, meaning it will hold a maximum of 8 electrons. So atoms in the periodic table, elements 1 through 10, will have will have up to 2 energy levels. 1 and 2, hydrogen and helium, will just have the first energy level, and then all the remaining ones from 2 up to 10 will have 2 energy levels. And then there's a third energy level which has 4 orbitals and also holds 8 electrons. So that means up to 18, which is argon, will have 3 energy levels. But the important aspect of this is the fact that the valence level, the outer one, does not fill up unless it is in that last column, which includes argon, neon, and helium. Those are the noble gases, and they're filled with electrons. So the more electrons an element has, the more likely it will be to take electrons, and elements with more equal numbers will share the electrons. Call this property its electronegativity. It's an important term, electronegativity. Basically, the more electrons that are in the valence level, the more orbitals that are filled, the more electronegative it is. So the very most electronegative element is element 9, fluorine. It's the one that's right before you get to neon, which is a noble gas. So the noble gases have 0 electronegativity, meaning they're not going to want to take or share their electrons because they're full of electrons. But fluorine with 9 has 7 electrons in its outer valence level, which means it's going to have all but 1 electron in that outer energy level, which means it's going to strongly take an electron from something else. It's for that reason why hydrogen fluoride is one of the strongest acids that we have on Earth, because it so strongly takes the electron from hydrogen. So remember that electrons will first fill any open orbitals, then second pair within the orbitals. So if you wanted to talk about how this would fill, let's pretend I'm filling electrons for, say, fluorine. So again, we're talking about element 9, which means it's going to have 2 electrons here in that inner energy level, and then the third would go here, so that's where lithium's electron would be. Then 4, 5, 6. So this would be what carbon's electron configuration would be. Then we pair in each orbital. So that would be neon, that would be oxygen, and then this would be fluorine, which then leaves that last outer orbital unpaired. But again, is the reason why it has such a strong electronegativity, because it's going to strongly take an electron from something else to fill that energy level. So what we're first going to talk about are the ones that are going to share electrons, and those are going to be the ones that are going to form covalent bonds. So they're going to be ones that will form a bond or share electrons between the two of them. So this would generally be, in the case of biology, between carbon and hydrogen. So carbon has each orbital with one electron. So it's always going to share. So covalent bonds form when two or more elements share their electrons. Compounds that form covalent bonds are called molecules. So water is a famous molecule. So you have oxygen here, and you can see its electron configuration in red. And then hydrogen has its electron configuration in blue. So oxygen is going to share its electron here, and it's going to share its electron here. So it's going to form two different covalent bonds. So this is called the Bohr model. And then you have the Lewis model. And oftentimes in the Lewis model, you might actually draw in these extra electrons over here like that. And then if you were making a 3D model of water, that's what it would look like with the model kits. So one of the things you need to be able to do is identify the number of bonds that something can form. So the 4 key elements that are found in living things, you spell out the word honk, that's why I have a trumpet there, that would go 1, 2, 3, and 4. So hydrogen forms 1, oxygen forms 2, nitrogen forms 3, carbon forms 4. And there's other ones in here, helium, neon, and argon. Those are the noble gases, so they're filled. So you can see these are the Lewis dot structures for these. And you can also know that the ones that are in the same column are going to have the same number of electrons formed. So some examples of these are going to be structural formulas. So this is the chemical formula for CO2, carbon dioxide. This is how I would draw it using like the Lewis dot model. And then when you draw it in just the structural formula, you draw each of these bonds as a double bond. This is ethanol. So oftentimes you could just write ethanol's molecular formula like this, but a lot of times you do it so that you can actually see how the molecules kind of go together. So it forms CH3, CH2, and then the OH. So you would write it that way. Propylene glycol, CH3, and then CHOH, and then CH2OH to show where that would go. And then this is phenylalanine. And one of the other things that I'm noting here is phenylalanine, you could draw it out like this. Oftentimes in the case of organic chemistry, the larger structures, you ignore the carbons and hydrogens and just draw the shape, noting that each of the corners is going to represent a carbon with any hydrogens that would need to be there to fill up the total number of bonds coming from carbon and hydrogen, which would be 4 from each carbon and 1 from each hydrogen. So if the 2 or more atoms involved in forming the compound have an extreme difference in numbers, meaning they have a difference in electronegativity of greater than a certain amount, they're going to form ions when they interact with each other, meaning one is going to take electrons and one is going to give electrons. So the one that's more electronegative is going to take the electron, the one that's less electronegative is going to give. So generally what we're talking about here is elements that are found at opposite ends of the periodic table. So the ones on the right side of the periodic table are more strongly electronegative, and then the ones on the left side of the periodic table, like where calcium and all, those are less electronegative, so they're going to become positive ions. So oxygen, for example, is going to become an oxide ion. So looking at these, you should be able to determine whether or not they would become givers or takers. So fluorine, strongly electronegative, it's definitely going to be a taker. So it's going to take one electron. Sodium has one electron in its outer ring. It's going to give that away. Sulfur has, boron has 5. I thought that was an S. That's a boron has 5. It has 3. It's also going to be a giver. So it's going to become a +3 ion. So sodium fluoride is an example. That's the main component of toothpaste. And how this forms an ionic bond, you'll see the red electron from sodium is going to be added to fluorine. And after that happens, you change the charges of each, and the opposite charges attract. One thing to note is the ionic bond strength is about 1/10 that of a covalent bond. So molecules are much more stable than ionic compounds. So acids, bases, and salts generally are going to be ionic compounds. Now there are some acids that are molecular in structure, but they'll have components of it where they will lose hydrogens or gain hydrogens as a way of becoming an acid. And we'll talk about that when we talk about the properties of water. So an ionic bond is two elements give up or take electrons. Givers become positive ions, takers become negative ions, and the opposite charges hold them together. So in summary, most elements are unstable because they don't have a filled outer energy level. Elements that have a filled outer energy level are stable and are called noble gases: helium, neon, argon, etc. In order to become stable, elements will bond with other elements to fill their outer energy levels. So a compound is made up of two or more elements bonded together. There's two types of compounds: molecules, which contain covalent bonds, and ionic compounds, which contain ionic bonds. Covalent bonds are where unpaired outer electrons are shared. They can share 1, 2, or 3 electrons, meaning they form a single, double, or triple bond. The number of bonds an element will form is equal to the number of unpaired electrons in the orbitals. So a covalent bond, a common one you could see would be CH4, that's methane. So carbon has these 4 outer ring electrons. Then you have hydrogen, which will have one electron that will then share around. Okay, the second part of the summary. Most atoms have 4 orbitals in their outer energy level. Each orbital holds 2 electrons. Each orbital first fills with 1 electron, then additional electrons added will pair. If an atom has unfilled orbitals, in order to be stable, it will lose its electrons so that the next innermost ring will become the new outer ring. As a result, it will become a positive ion. So again, if it has at least 1 unfilled orbital, meaning totally unfilled, that means that none of them have at least a pairing in them. So you can never have an orbital. You're never going to have an orbital or an outer ring like this. So imagine these are the orbitals that I'm marking here. So that's an orbital. You're never going to have one that's like paired like this, and then the other ones are not filled. That can't happen. You always have to have 1, 2, 3, 4, and then you pair. That's what happens. So if you have at least one unfilled, that means that none of them are paired, and that means it's going to become a positive ion. And then this should show you why the ions that are positive are going to be only ever up to +3, because these 3 would probably be lost, or the other ones would be lost. So if it had 4, it would not form an ion, it would form a covalent bond. So if an atom has a filled orbital but is missing just a few pairs, it takes electrons from another atom that would become a positive ion. As a result, it would become a negative ion. So again, if it takes, it's negative. If it loses, it's positive, or you could also say if it gives. Okay, so sketch an ionic bond. Common one is sodium. And then if I take chlorine, it's going to have 7. It's in that same row as fluorine. And what's going to happen is this is going to move over to there. This one will become positive. This one will become negative. And their opposite charges attract. So that's the basics of bonding between atoms, the covalent bond and ionic bond. All the remaining stuff, and being able to identify different types of covalent bonds. So for example, there are non-polar covalent bonds and polar covalent bonds. We're going to talk about that later.